Hello guys, basically I'm trying to make a bit of a review of the EFAP crowd's discussion today about Mandalorian, but specifically this scene out here where he ties himself up to a flying TIE fighter, and well, basically his hand should be ripped off, but it's not. The guys were talking about that, speaking how that's, taken out our suspense of disbelief. I don't know if you know who EFAP are, but they're basically great at cyber frame of house. They're movie reviewers, and basically the comment section was going on fire, and the guys were going on fire. They were talking how this would be ridiculous, but nobody seemed to be able to calculate the simplest equation that would take to calculate the actual G-force. I mean, I've seen a lot of stuff in the comment section, and everybody was just horribly wrong. So I decided to make this quick video. At least I'm going to try to keep it quick, but Now, I'm a mechanical engineering major student, so you can trust me on that one. Trust me, I'm an engineer, but really the math in this particular case is basically, it's 7th grade physics math. Okay, so first things first we're going to do is we're going to have to make a snippet of this right over here, which I already did. Make a snippet of this particular scene and save this snippet to figure out what's the length of this area right over here. Now we need that. I'm going to jump over to Autodesk Inventor. This is a CAD software that allows me to basically, well, it allows me to do a lot of stuff in my regulars, but right now I'm just going to be using it to scale the picture, right? So I'm going to open up the snippet. Get this out. Now I'm gonna quickly draw this up. Now I know that Pedro Pascal is 5'11". That makes him 180 centimeters tall. Now if we consider the fact that there may be some parallax at hand or some other crazy stuff, what we're gonna do is we're gonna consider him to be 200 millimeters, 2,000 millimeters tall, which makes them 2 meters tall. It scales up the whole texture. Now I'm just gonna take the measurement of this side. Now it's around 45 meters. Once again, the measurements are in millimeters, so if it's around 45 meters, we can actually consider it to be, once again, due to parallax and all the craziness possible, we're gonna consider the length actually to be 40 meters. Okay, so don't need that anymore. If the length of the shot is 40 meters, we can also estimate approximately how long does it take for the TIE fighter to go by. Now, I'm not going to actually download the video. I don't want to do that. I'm making a response to something in the comment section that most likely nobody's never going to see anyways. Although the guys did speak of wanting somebody to break this down scientifically. And, well, here it is. Hope you guys see it. So we can approximately estimate that to be around 1/3 of a second if we consider it to take a bit over the second at 0.25 times the speed. Once again, I'm going to estimate it to be around 0.3 seconds. Now, if we're going to do that, now let's jump over to MATLAB. Now, this is basically an advanced calculator, and I'm not going to use any of the advanced features. What we're going to have to do first is figure out what is velocity. So we took the length and we estimated the times purely to figure out the velocity of the TIE fighter. Now the velocity of the TIE fighter ends up being approximately 40 meters over 0.3 seconds. Now that ends up being around 133. We're going to estimate it actually to be velocity to actually be 120, just because it's always better to take small numbers and prove your point anyways. So 120, velocity is going to be equal to 120. If we have velocity is equal to 120, what is acceleration? Acceleration is the time it took for the change in velocity. Now in this particular case, we know that Mandalorian actually has no velocity at the initial point. I mean, no, to be more precise, he has no velocity horizontally, he has no x velocity. And that's the only velocity that matters because that's the direction that the TIE fighter is going in. Now, if we consider that to be true, it actually does something smart in a sense that he's a bit higher than the than the TIE fighter, which would give him a bit of a benefit purely in the sense that when he attaches himself, he actually gets that force applied under an angle, and that angle is moving. So in reality, the G's will actually be a bit like he would have it spread out over a bit of a longer time. But purely because, you know, the wire has to catch it up, and it's going to be pushing him down as well as pushing it to the side, creating a weird vector that's going to be changing, which is going to equalize the force applied G-force wise, purely because that allows, and because since you have different angles at which the G-force is affecting you, it's not affecting your body that bad momentarily. But realistically, at the time that it's going to take to do all this, it doesn't matter really. We can estimate his acceleration time to be, let that be around 0.05 seconds. Once again, this is just a pure wild estimation. Now, if we have it at 0.05 seconds, in this particular case, then if the time is 0.05 seconds, then the acceleration is going to be going up to 120 meters per second over a time period of 0.05 seconds. I'm estimating this number. It's not given on here. It's definitely not a given the way this scene works over here. It takes way longer than it should. It would not take him that long. It basically would be like getting hit by a car. Just instead of being hit by a car, you're being yanked by a car. And by a car, and when I say a car, I mean a Bugatti Veyron at nearing top speeds, by the way. On that rail, it's around 200 miles per second, miles per hour. This speed over here is around 200 miles per hour. So the acceleration we get is around 2,500. It's actually 2,400 meters per second squared. Now the G-force, everybody constantly speaks of G-force. Is basically what G stands for. Really, is 1G is the gravity of Earth. The acceleration that the gravity force on Earth produces. In other words, if you're in free fall, you're falling at you're accelerating at 9.1 meters per second. You're accelerating a speed of 9.1 meters per second at every second. But we use G-force to compare acceleration or the force that is trying to produce this acceleration upon you in different kind of situations. For instance, most popularly it's used for cars, or it's used for jet fighters, or any kind of acrobatics pilots, basically, because they experience high accelerations due to constant change of the vector. Actually, Mandalorian should be experiencing a lot of it right here as he's being yanked around to different sides. Because all those are accelerations. He had no velocity to that side, and now he achieves velocity to that side, which means that he's being accelerated. Now, these kind of accelerations are very different. First things first, what we're going to do is we're going to discuss the fact that when a fighter jet pilot can only experience around 9 Gs in a special suit before he passes out, well, most of them can experience a bit more, but let's cut it at 9, because most machines can't take it further than that. When we call that 9 Gs, what you have to accept is that that's not a second. They experience that acceleration for several seconds, usually. It's not a momentary thing. When you have to experience the acceleration only for a split of a second, it's rather different. And the way it's rather different is, the way it helps, and the fact that it's rather different is that when you have to experience it only for a split of a second, you can take more. You can definitely take more, and as a point of comparison, here's a NASCAR's crash was measured at 193 Gs. It was an IndyCar crash. Doesn't really matter. Basically, this seems to be the highest G that anybody has survived, for all I could find in a quick Google search. Now, this is a momentary G. This G force was registered during a crash. It was for a split of a second between changing directions. So it's very applicable to the way the G-force is being applied to Mandalorian over here. Well, what the hell has Mandalorian experienced and survived? This over here is 2,400 meters per second. A G-force, acceleration of free fall, is 9.81 meters per second. Now, what we gotta do is for us to find out what's the G-force, we're gonna call it G-force. It's not a force, but you know, it's a very common misconception, so we're just gonna go with it also. It's gonna be A divided, which is 2,400, divided by 9.81. And we get 244 Gs that Mandalorian has been experiencing at the second. Now, could he have survived that? Very unlikely. If we consider that this is the highest G that anybody has ever experienced, even for a split second, it's very unlikely that he would survive that. Would he pass out? Most definitely he would pass out. At least for several seconds he would pass out, including the fact that he's being yanked around afterwards for God knows how long. Well, changing direction, etc., etc. He's not operating anything. Right now, he should be passed out, completely passed out. So, what can we know for sure here then? We know that the G-force is 2,400. Oh, the G-force is 244. Now we can calculate. We could calculate it even before, but we can calculate what force is being applied to his hand right now. Now we can calculate it two ways. Basically, for me to actually calculate a force, I'm going to go with force is equal to mass multiplied by acceleration. Acceleration is 2,500, and force is going to be, and the mass is going to be definitely over 100 kilos, including the fact how much he's carrying on him, and the fact that a dude who's 180 centimeters is definitely at least 80 kilos all by himself. So we're gonna run with that number approximately, and we get 240 kilonewtons, or 240,000 newtons. Now, for us to find out what's that actually compared in weight, quick comparison would be, and we don't have to calculate this from here, we can just take the G-force multiplied by 100, and we get this crazy number over here, which actually is over 24 tons. So what this is telling us is that the force that is being applied to Mandalorian's hand when he's being yanked is equivalent to 25 pounds, to 25 tons, metric tons, being suspended from his hand at that particular second. Imagine 25 tons being hanging from your hand, even for 0.05 seconds. It's gonna rip it off. It's gonna rip your hand off clean. It's not gonna break it, it's gonna rip it off. That's 25 cars, to give you a bit of a reference. Alright guys, this took a bit longer than I expected, but I hope it was informative. And the EFAP crowd, if anybody of you is going to actually see this video, I really hope you do. If you need any, science breakdowns, let me know.